Mathematics and computer science often involve the process of generalizing statements. By generalizing a statement, we mean to include new situations or states. Here's an example. A kid observes that adding 1 to 0 yields an odd integer, 1. Adding 1 to 2 yields an odd integer, 3. The kid sees a pattern and guesses that adding 1 to an even integer yields an odd integer. The kid generalized the statements adding 1 to 0 and adding 1 to 2 to adding 1 to an even integer. Here's a silly generalization. The 5 Irish boys I know all have red hair. I generalize to all Irish boys have red hair. Here's a good example. Some mathematician knew that the sum of the angles of a triangle was 180 degrees. The mathematician figured out that the sum of the angles of a 4-sided convex figure was 360 degrees. The mathematician then generalized these facts to the case of n sides. That mathematician saw a pattern, generalized, and proved the generalization. Here's a neat example. We have an 8x8 kitchen with a 1x1 refrigerator on one of the squares of the grid. Elaine wants the kitchen tiled with L-shaped squares. That's 2x2 squares with one corner removed, covering every square except the one on which the refrigerator sits. How do we do that? That's difficult. We don't even know whether it can be done. We get a handle on the problem by generalizing. We have an 8x8 kitchen. That's a 2 to the power 3 by 2 to the power 3 kitchen. Generalize that too. Tile a 2 to the power n by 2 to the power n kitchen with one square covered. Then we will be able to tile the kitchen using recursion. We don't do that here. Without the generalization, this is a very hard problem. With the generalization, anyone who fully understands recursion can solve it. Generalizing too much may lead to an unsolvable problem. For example, suppose we generalize to tiling an n by n kitchen with one square covered. That can't be done, as you can see, by trying to tile a 3x3 kitchen. In the domain of loops, generalization will help us find loop invariants. When we start developing a loop, we have a precondition and a postcondition, R. R is true after the last iteration. Invariant P is supposed to be true after every iteration. Hence, P can be viewed as a generalization of R. We try to generalize R to a situation in which simple initialization can make P true.